Welcome to part 7 in my derivative rules series of videos. In this video, we're going to learn how to knock out derivatives with the quotient rule. Don't forget to like and subscribe before you begin so you can continue to get all these amazing videos. All right, let's dive right into what the quotient rule states. If f of x and g of x are both differentiable functions, then f of x divided by g of x is also a differentiable function, and here it is. The derivative of f of x over g of x. So here we got a function divided by another function, hence the quotient rule. Here is how you find the derivative. Take your time. You start off with the denominator. Leave it alone. That's just g of x. You multiply it by the derivative of the numerator. The derivative of f prime of x, the derivative of the numerator. Then you leave f of x alone. So you subtract, minus, leave the numerator alone, and you multiply by the derivative of the denominator. That'd be g prime of x. And here's the best part. You divide everything by the denominator squared. So in the denominator, there is no derivative. It's just whatever your old denominator was from the original function. You take that same denominator and you simply square it. That's it. That's how simple it is. So again, keep in mind, you start with the denominator. Leave it alone. Multiplied by the derivative, f prime of x, of the numerator, minus, now you leave the numerator function, f of x, alone, and you multiply by the derivative of the denominator. Now, because we're subtracting, order matters. So if you get the numerator out of order, you're going to get the problem completely wrong. So please be very careful as you're using the quotient rule that you're following it appropriately and you're not using it in the wrong order because you'll get it wrong. Now, here's another way of looking at it. That's actually how I prefer to look at it this way, mostly because it's how I was taught back, 25 years ago. But when you are looking at the derivative of u divided by v, where u and v are two separate functions, numerator, denominator, you simply start with the denominator, leave it alone, that's v, multiply by the derivative of the numerator, which is u. So remember, we express the derivative of u as du over dx, the derivative of u. Minus, this time you leave the numerator u completely alone, and you multiply it by the derivative of v. Again, that's the denominator, dv over dx. That's my notation for the derivative of v. And you divide it all by the denominator v squared. No derivatives in that denominator, just the denominator squared. It's really, really, really that simple. So, hope that all makes sense to people. And again, go back and hear me explain it all again, but I just want to dive into some examples where we actually utilize these rules. All right, so here is a beautiful problem all set up for me to go. I got a numerator, I got a denominator, I got my u, I got my v. Now I got to attack it with the quotient rule. All right, here we go. Following the quotient rule. Start off with v. Leave it completely alone, x plus 1. Multiply by the derivative of u. The derivative of x is just 1. It requires the power rule. The 1 falls down as a constant multiple out in front. New power is 0, but x to 0 is just 1, hence just 1. Minus, now I'm going to switch this around. Now I'm going to start with u, which is x, and I'm going to multiply by the derivative of v. The derivative of v is also 1. The derivative of x is 1. The derivative of 1 is 0, so that's how I just get 1. Now, I want to just emphasize what I did there. Notice I always put parentheses. When I follow the quotient rule, same as when I follow the product rule, if you've watched that video, I'm always putting those values in parentheses. Because if you forget to put them in parentheses, sometimes you view it as addition or subtraction instead of multiplication first. Got to really emphasize order of operations. But I'm forgetting one more part here, all divided by the denominator in its current format, completely left alone, squared. Done. I am now done using the quotient rule. I'm now going to move on to cleaning the problem up, which is actually where a lot of students make mistakes. So let's properly clean this up. First, I'm going to distribute 1. 1 times x is x. 1 times 1 is 1. Now I'm going to distribute the negative. So it's negative x times 1, which is just negative x, all divided by x plus 1 squared. Now, quick note about the denominator. I could actually square that out and get x squared plus 2x plus 1, but it's actually easier in the world of mathematics if I leave it as just x plus 1 squared. It actually looks better, looks more simple. Now, on the top there, I'm going to look at the fact that I got some common terms that I could combine. This x and this negative x are going to add up to a 0, so I just get 1 over x minus 1 squared as my final derivative. I really want to emphasize that what's done in green there is the quotient rule. In red, I'm just doing algebra to clean the problem up and make it a little bit more simpler. So please be careful because a lot of students make the mistake in the cleaning up of the problem as opposed to actually in the quotient rule. All right, slightly more difficult problem here, just a little bit more to do. But I got my numerator, 4x cubed minus 7x. Got my denominator, 5x squared plus 2. That's my u, and that's my v. And I'm going to dive right into using the quotient rule. So y prime, the derivative of this function, is going to start off with v. Always start off with the denominator left alone. There it is. There's v. Now I'm going to multiply by the derivative of u, which is going to be 12x minus 7. Use multiple rules there. I use the constant multiplier rule, the power rule, the difference rule. So hopefully you understand all my work there. Minus, okay, here I go. Now I'm going to start off with u, left completely alone, 4x cubed minus 7x. And I'm going to multiply by the derivative of v, which is 10x. Again, power rule, 2 falls down in front, 2 times 5 is 10 times x. And then the derivative of 2 is 0, so just 10x. And then I'm going to divide it all by my current denominator, currently completely left alone, squared. Make sure you put parentheses around it, because it's not just, some kids will say, oh, that's 25x to the fourth plus 4. No, it's not. It's the entire denominator as a quantity, 5x squared plus 2, all squared. All right, again, now what I'm going to do in red is the cleanup work, which is where a lot of students mess up, so take your time. Whole lot of fun distribution going on here. Here we go. That is going to be 5 times 12. If you need a calculator, don't be afraid. 60x cubed. 5x squared times negative 7, negative 35x squared. 2 times 12, 24x. 2 times 12x, excuse me. 2 times negative 7, negative 14. Now I got to be super careful in the back. I do have to distribute the 10x, but I also have to distribute this negative sign right here as well, because that negative sign is getting to be run through. So I have negative 40x to the fourth, positive 70x squared. Because the negative 4x cubed became a negative, the negative 7x became a positive. So please be very careful with all of that. Oh, it's a long division line there. Divided by 5x squared plus 2 squared. Again, you have the option to square out the denominator, but it's actually easier and more simplified if you just leave it. It's again, there's only one x. Why would you make more x's? So I actually like that denominator just completely left alone. All right, now in the numerator, I got to combine some terms here. So I got a negative 40x to the fourth. I got a positive 60x cubed. I got a negative 35x squared and a 70x squared. That's going to make a positive 35x squared. Combine those like terms. I got a 24x minus a 14, all divided by that 5x squared plus 2 squared. And I think it's easier if you just leave that alone. All right, let's turn our attention to another problem that's going to be a little bit trickier because we got a square root in there. So I still have a numerator and I still have a denominator, so that's why I'm going to use the quotient rule here. I am going to rewrite this though, and you'll see why in a second. It's going to make it a little bit easier to use the power rule. I'm going to write that x, the square root of x, as x to the 1/2 power plus 1. It's the same thing. And then now I'm going to view this as my u over my v so that I can go ahead and jump into using the quotient rule. All right, start off with the denominator. X to the 1/2 plus 1, completely left alone. Multiply by the derivative of u, which is 3x squared. Pretty simple derivative rule there. Minus, now I'm going to leave the numerator alone, x cubed, that's my u, totally the same. And I'm going to multiply by the derivative of the denominator. Now that's what's going to be a little bit tricky here. The 1/2 falls down in front, x to the negative 1/2 plus 0. So again, be careful with that one right here. Find the derivative of this part right here. Just take your time. 1/2 falls down in front. 1/2 minus 1 is negative 1/2. Be careful with all that fun stuff. All divided by my current denominator. And I can actually leave that as the square root of x here because I'm actually going to prefer to just leave it exactly like that. Now this is where we're going to have some time. By the way, I'm done with the quotient rule. The tough part is going to be actually cleaning this one up a little bit here. So let's see if we could do this. So first I'm going to do a little bit of distribution here. Now be careful, right? Don't let exponential or exponents that are fractions confuse you. So when I have x to the 1/2 times 3x squared, that's going to be 3x. And remember, we add those exponents. So 2 plus 1/2 is 2.5 or 5/2. And then I'm going to multiply this right there as well. So I get 3x squared times 1, which is 3x squared. Now back here, I have a monomial times a monomial, so no need to worry about any distribution. But it is going to be a negative, so don't forget about that negative there. So let's see here. I have negative 1/2 x, and again, add the exponents, 3 plus negative 1/2, that's going to be 2.5. 3 minus 1/2, 3 plus negative 1/2, 2.5, and that's also 5/2. That's actually a good thing because now I'm going to get a like terms that I can combine. And then don't forget that common denominator is the square root of x plus 1 all squared. All right, now there are some like terms here because I do have that x to the 5/2 and another x to the 5/2. So let's see here. So I have 3 minus 1/2, combining those like terms. Okay, 3 minus 1/2 is 2.5 or 5/2. So I actually get 5/2 as my coefficient. X to the 5/2 plus 3x squared, all divided by that denominator plus 1 squared. Now, I'm not going to lie, that's not the prettiest answer in the entire world, but it works. I mean, remember the whole point of what a derivative is. It's a formula to help you find the slope at any given value. So it's more important that it's correct rather than you make sure it's pretty. If it's correct, it's going to do exactly what you need it to do, which is give me an x, I plug x in, and I get the rate of change at that given point. So don't worry about how pretty or unpretty it looks. Just make sure that it's correct. That's what matters far more. All right, one more problem for your entertainment here. Once again, I have a numerator, 2x cubed plus 3, denominator, 4 times sine of x, and I have my u, got my v. Let's dive into finding f prime of x, the derivative of this function. Start off with v, 4 sine of x, times the derivative of u, 6x squared, plus 0, but obviously don't need to write the plus 0, minus, now I'm going to leave the numerator alone, 2x cubed plus 3, times the derivative of the denominator, which is going to be 4 cosine of x. 4 is a constant multiplier, so it just stays. The derivative of sine is cosine, so 4 cosine of x. All divided by 4 sine of x, all squared. Whew, okay, let's see if we can clean this up a little bit. Now, not a ton of cleanup work to do here, but let's see here. Now, I could actually get rid of these parentheses because this is a monomial times a monomial, but I'm going to move the 6x squared in front of the, well, actually, I'm going to make that a 24. I'm so sorry, because I can multiply that 4 and the 6 to get a 24. That would be very smart of me. So 24x squared times sine of x. Now, the reason why we actually prefer that the x squared be in front is because if I write 24 sine of x, x squared, people will say, well, is that x squared separate or is that x squared in the sign? Could I make an x cubed? And the answer is no, because the sine of x is its own value. So it's a little bit easier if I put that x squared out in front, that way I see that. All right, back here, I mean, I guess I could distribute. I got to be careful to distribute this, and then don't forget about that minus sign. So it's going to be minus 8x cubed cosine of x minus 12 cosine of x. Okay, again, it's not very pretty, but it works. Now, again, you could actually leave the denominator just like this, but that's a monomial, right? There's no plus sign in there. So I could actually square that out and get 16 sine squared of x. I mean, that makes sense. That's pretty easy to do. That's not going to create more x's. It's pretty simple. But again, I would have no problem with you just leaving as 4 sine of x quantity squared. Either way works here. But again, I want to emphasize one more time, same thing I said on that last problem. It doesn't look very pretty. It's not. I'm sorry. You're right. But it's going to do its job. If you have an x on this function, plug that x in and you'll get your rate of change. So again, don't worry about how pretty it works. Excuse me, how pretty it looks. Just make sure that it works and it does what it's supposed to do. And all that means is that it's right. All right, that's it for the quotient rule. Hopefully you liked it. Hopefully you enjoy it. And hopefully you'll get some good practice with it. See you later.